Okay, level 4 is finding the distance from a point to a line. There's a couple different steps in order to do this, so I'm going to take you through each one. First, we need to define what an altitude of a triangle is. The altitude of a triangle is a line segment from the vertex that's perpendicular to the opposite side. The same can be said about the shortest distance between a point and a line. So basically, what we're looking at here is if I have this triangle and I want to know the shortest distance, so from this point up here to this line down here, I could draw a bunch of different lines going up and down, up and down, up and down. But the shortest distance, or the one that will always hold true, is the one that's perpendicular to that line down below. Okay, so that's how we always mention, and you'll do this in calculus when you get there, is that you will always find the distance from a point to a line to be the perpendicular distance, otherwise known as the altitude. So if we find the equation of the altitude of the triangle when you have those vertices listed from vertex A. So I'm going to plot these points. So I have a nice picture about what's going on. Okay, and now I'm going to draw, or try and draw as close to I can, an altitude from the vertex A to the opposite side of BC. Okay, write the equation of the line of the altitude. So basically what we want to do is we want to write an equation of a line that's perpendicular to the BC and it goes through A. Okay, much like we have been doing in level 2 and 3. So perpendicular line to BC that goes through point A. So what I need to do is find the slope of BC. And that's going to be -1. So the perpendicular slope is going to just be a +1. And then the only point that we know that it goes through is point A. It doesn't say it goes through the midpoint or anything on BC. So y minus 5 equals 1 times x minus 4. And just for the sake of practice, let's go ahead and write this in slope-intercept form. It's going to be -4, and then when you add the 5 over, it will be a +1. Okay? Now it says find the intersection point between the altitude from AB to BC. So what we want to do is we want to find the equation of BC and find out where find out where the altitude meets line BC. So we would use either substitution or elimination, or we could graph the two lines after we finish writing the equation of it in our calculator. So let's find BC. So I need the slope of BC. We already have that. That's 1. And we just need one point that goes through BC. So let's just pick -4, 1. So y minus 1 equals -1 times x plus 4. Okay, and then to find out where they intersect, since they both equal y, again, you can do substitution or elimination, or you can put them in your calculator and graph them and find out where the intersection is. Since they both equal y, this is fairly simple. You just set them equal to each other. So then this is going to be -4. So x equals -2. And then if I substitute it back in, y is going to equal -1. So the point of intersection, it's a big key here, is -2, -1. And the last thing that you want to do is now find the distance from A to BC, otherwise known as the distance from a point to a line. So the shortest distance from a point to a line so far, what we've done is we've written the equation of the perpendicular line through the point. We've written the equation of the line that it intersects and found the intersection of the altitude and the line it intersects. And now what we're going to do is use a distance formula between A and the point we just found. So A is 4, 5, and we just found the point. Let's call this point D of -2, -1. All right. So that would be your final answer.